Hi, I welcome you all for SVK coaching classes. In the previous session, I have explained you the Bessel solution using a differential equation. We got an Bessel solution in terms of Jn of x, right? So using that Jn of x leading to 0, I am going to consider alpha and beta are two roots, distinct roots, and I am going to prove that integral from 0 to 1, x into Jn alpha x, Jn beta x is equal to 0. Today I am going to prove this result as we know that Jn of x is equal to 0. So if this is the statement, if alpha and beta are two distinct roots of Jn of x equal to 0, then prove that integral from 0 x equal to 0 to 1 x into Jn alpha x, Jn beta x is equal to 0 for alpha not equal to beta. For alpha not equal to beta, where alpha and beta are distinct values. So that's why we are said which is not, both are not equal. Next, so we know that Jnx is a solution of the differential equation x square y double dash plus x into y dash plus x square minus n square on y equal to 0. As I have taken here lambda here, so x will be multiplied with lambda square here. So therefore Jn lambda x is a solution of the equation of the form differential equation of the form x square y double dash plus x into y dash plus lambda square x square minus n square on y equal to 0. So after knowing this, thus we can say that I am going to define u as in terms of Jn alpha x and v as Jn beta x. What I am going to define u and v as Jn alpha x and v as Jn beta x. We have respectively x square u double dash. So in place of lambda x, I have considered alpha x, right? So therefore y becomes u here, as y equal to, instead of y we are taking u here, so this becomes u double dash and u dash here alpha. In place of lambda, what we have, alpha we have, so it becomes alpha square x square minus n square u equal to 0. Similarly, you can guess what will be for v, the differential equation. For v, the differential equation will be x square v double dash plus x into v dash plus beta square x square minus n square on v equal to 0. So I am going to distinguish those two equations as equation 1 and 2. These two are the two main equation for to execute with the solution. So next, multiplying equation 1 by v by x and multiply the equation 2 by u by x. What I am going to do? Multiplying the equation 1 by v by x. So if I multiply by v by x, x get cancelled in the first term. So I am going to get x into v u double dash as I am multiplying v here. So x into v into u double dash plus x get cancelled, v into u dash plus something that is what here we have alpha square x square minus n square u. You can multiply u inside, and also multiplying v by x, we are going to get an equation xv u double dash plus v u dash plus alpha square u v x minus n square u v by x. As I have multiplied u inside and with the term called v by x, I got these terms like alpha square u v x minus n square u v by x, which is equal to 0. Similarly, I will name that as equation 3. Similarly, if you multiply equation 2 by u by x, you are going to get what? You are just going to get x into x into u v double dash plus u into v dash plus alpha square u v x minus n square u v by x. You can observe here. Instead of alpha square, we are going to get beta square. That's all. So I will name that as equation 4. Now to come with a result, I am going to make use these two equations 3 and 4. I am going to subtract equation 4 from 3. I am going to subtract equation 4 from 3. Let us see what we are going to get. See the beauty of this equation. Subtracting equation 4 from 3, we get x into v u double dash minus u into v double dash. How? You can go through once. As I am subtracting these two equations, here we have these two second order derivative. We have here x into u v double dash minus x into v u double dash. That is from those two equations I have a common term called x. I have taken out that. Similarly, if you subtract these two first order derivative, you are going to get uv dash minus v u dash. Similarly, these two x variable, and as we have same sign and same term here, these two term get cancelled. N square uv by x and n square uv by x get cancelled. You are going to left out with what? Alpha beta square uvx minus alpha square uvx. So I can write that as what? You are left out with a constant term called, this is the second term, uv dash minus v u dash minus uv dash, and finally plus alpha square minus beta square uv x equal to 0. This is the what equation we got after subtracting those two values. And then now I am going to this is nothing but I observed that this first two term is as same as UV rule. It is of the form UV rule. So U into V. If you observe here, this let us retain this as U and differentiate this part. We are going to get V into U double dash minus U into V double dash. Plus derivative of x will be what? Differentiation of x is 1, right? So using that UV rule, I can write this can be written as derivative of x into v u dash minus v into u into v dash. I can write d by dx of x into v u dash minus u into v dash, which is equal to, I have shifted this to right hand side. This becomes what? Beta square minus alpha square. As it becomes negative, multiply by negative sign, I am going to get what? Beta square minus alpha square. Since earlier it was what? Alpha square minus beta square. If you shift this term to right hand side, it becomes, as it is plus sign, it becomes minus alpha square minus beta square. So multiplying by minus sign, it becomes minus into minus plus beta square minus alpha square times of uvx. So now integrating on both the side with respect to x and taking limit as x runs from 0 to 1. Now I am going to do here, I am going to integrate this equation on both the side with respect to x, taking the limit x runs from 0 to 1. As we have derivative here, integration is nothing but antiderivative. We can say that, so derivative and integration get cancelled. You are left out with what? X times of v u dash minus u v dash. Limit x runs from 0 to 1. Limit as x runs from 0 to 1, which is equal to beta square minus alpha square is a constant. You can take out that and integrate uvx with respect to x, taking limit x runs from 0 to 1. Now substituting the limits here, substituting the limit, lower limit and upper limit. So here when x equal to 0, when I give x equal to 0, the whole term vanishes. When I substitute lower limit, the whole term vanishes. You are going to left out with only the limit with x equal to 1. So that is what I have written here. This implies as the term, if I substitute the limit as x equal to 0, the second term will be vanishes. So therefore you are left out with as x equal to 1, and also I have substituted x equal to 1 here. Putting x equal to 1, you are left out with what? V u dash minus u v dash, as u and v are parameters. So therefore putting x equal to 1 as it is limits. since you know that u and v are depending on the functions of x. U is defined as jn alpha x and v is defined as jn beta of x, beta x. That's why. So which is equal to beta square minus alpha square, integral runs from 0 to 1 uvx dx. So name this as equation 5. I'm going to name this as equation 5. Now you know that u is what? Jn alpha x. U is what? Jn alpha x. So therefore differentiating u with respect to x on both the sides, you are going to get u dash equal to jn dash alpha x. U dash equal to jn dash alpha x. Similarly, v equal to what? Jn beta x. Differentiating that with respect to x on both the sides, we get v dash equal to jn dash beta of x, beta x. So from 5, substituting the above values in equation 5, what we are going to get? The beauty of this equation, see here, just I have substituted u and v dash, u v dash, u v, v dash, u dash I am substituting. So in place of v, jn beta x, in what is the derivative here? U dash is nothing but alpha into jn dash alpha x. Here I forgot to write alpha here. You can write that as alpha into jn dash alpha x, here beta into jn dash beta x if you differentiate. So that is what I have written here. Just I have substitute those values. So as x is running from limit 1, which is equal to beta square minus alpha square, integral 0 to 1 u v is what? Substitute that value, x retains as it is, x into jn alpha x into jn beta x dx. So this is what the equation 5 becomes. The equation 5 has become in terms of jn alpha x and jn beta of x. Now putting x equal to 1 in all the values, put x equal to 1, what you are going to get? Alpha into jn beta, alpha into jn beta into jn dash alpha minus beta into, I am taking out beta constant first term, beta into jn alpha into jn dash beta. That is what you are going to get when x equal to 1. When x equal to 1, so I have substituted here. See here, when x equal to 1, this is the value I have got, and I have cross multiply beta square minus alpha square, beta square minus alpha square, and I have got integral value. As my aim is to prove integral from 0 to 1 x into jn of alpha x into jn of beta x dx is equal to 0. Beta x equal to 0. So I got this fraction here. I got this fraction. So I will name that equation as 6. So since alpha and beta are distinct roots of jn x equal to 0, so we can have that jn alpha will also be 0. Just replace x by alpha. Jn alpha is also 0, jn beta is also 0, and we can say that beta square minus alpha square is not equal to 0, as the reason behind beta square minus alpha square is not equal to 0 is alpha is not equal to beta. Since alpha is not equal to beta, therefore we can say that beta square minus alpha square is also not equal to 0. So now substituting jn alpha equal to 0 and jn beta equal to 0, the numerator becomes what? 0 minus 0. 0 minus 0 is 0. 0 by a finite value is 0. So hence from equation 6 we obtain that the right hand side is 0 if alpha is not equal to beta. Hence we have proved the result called integral from 0 to 1 x into jn alpha x into jn beta x is equal to 0 if alpha is not equal to beta, as alpha and beta are two arbitrary constants. So thank you. I think you all understood. If you have any doubts, you can put any message in my YouTube chat there. So, and those who have not subscribed to my channel, you can subscribe. And if you wish to attend my offline classes, you can contact me. Thank you.